Hello, everyone, and welcome to another podcast from Mitsubishi Electric. And this time we are going to discuss a very difficult topic of cybersecurity. But the topic came up a couple of times already. Some people were asking about specific cybersecurity-related questions related to different industries. So finally, we decided to make it all about cybersecurity this time. But when I started working on this topic, I understood that it's gonna be quite complex. That's why today we are gonna discuss all the details related to cybersecurity in factory automation. And this might be one of the most difficult conversations I had, but serious topic requires serious discussion. And hopefully you will be able to use this knowledge to apply cybersecurity strategies to your companies. So this time I have a real expert in the cybersecurity topic, South African-born Frederik Kok. Welcome, and I'm very glad you're here.
Thank you. Thank you very much.
So Frederik will give us some of his knowledge around the topic. But the way how I usually start those conversations is going through, let's say, the surroundings. So the landscape related to cybersecurity in factory automation. So we will focus on this kind of operational layer for the time being. So could you tell us, let's say, what's going on recently when it comes to cybersecurity?
Yes, certainly. If I may, I would like to start with a quote.
Of course.
This quote is attributed to Albert Einstein. And he said, "I know not with what weapons World War III will be fought, but World War IV will be fought with sticks and stones." So what if World War III is actually a cyber war? Albert Einstein would not have known a cyber war. The term cyber was only coined decades later. But this war is happening all across the globe, and it's happening all the time right now. So when we look at this war, it's increasingly targeting critical infrastructure. And in the past, let's have a look back at the past where factories have been operating in an independent environment. So there's not a lot of risk, let's say cyber risk, when you talk about independent environment. But with the move to Industry 4.0, we see this transformation to the connected factory. And when you have a connected factory, you also have an increase in cyber risk. At the same time, there's an evolution in threats. We've seen a marked increase in ransomware, for example, which is directly correlated with the increase in cryptocurrency. Ransomware is just one example. So threats are increasing for various reasons. Also, because of this, governments around the world are introducing legislation, and this is enhancing and strengthening with a specific focus on infrastructure. Let's say operational technology. So when I talk about operational technology, I talk about factory automation and everything around it as well. So from various perspectives, OT cybersecurity, operational technology, OT, is becoming increasingly important. Now, I think with the introduction of the internet and the connected factory, these are very positive developments, in my opinion. But we are facing an increasingly hostile connected environment. Secondly, when you look at Industry 4.0, a lot more solutions need to be connected in some way, whether it's an IoT solution or an artificial intelligence, an AI calculation happening in the cloud. So you need to send something from the factory to the cloud. Whether it's remote access that needs to be done securely. All of these need to be connected in some way. Thirdly, when we look at sustainability, a sustainable society is a safe society. And when we look at safety in the digital economy, it means a cyber-secure society. So because of this, what we've mentioned before, governments around the world are releasing legislation specifically focusing on cybersecurity and then also on factory automation or operational technology.
So I think to summarize what you said just a little bit, it seems obviously the technological advancements are creating these amazing opportunities like data analytics and taking decisions directly on the factory floors and so on. But all of these amazing things actually cause, cyber threats, right? Because
exactly.
if you are connected, there is always an opportunity that someone will try to attack you, right? So, and that's why we should always have in mind the cybersecurity when we are designing the systems. And I think that you will give us some insights later how to do it. But let's talk about the legislation for a second, because when you were outlining the global trends related to cybersecurity, I think that this particular topic is, let's say, the one where legislation and the governments will be affecting it the most.
Absolutely.
One of these topics where everything depends on the governments. And could you give us some ideas how this is being done these days? We can focus on European Union just for the time being, but I think that, this is global trend as well.
That's right. So we will focus on some legislation within the European Union. Just to mention that Mitsubishi Electric is actively involved in some of this legislation around the globe, or actively monitoring this legislation. But like you said, we will talk about the EU-related legislation. And for this topic, we'll discuss the Cyber Resilience Act, so the CRA, and NIS2, which replaces NIS. So let's start with the Cyber Resilience Act. And we look at who does it affect? And in fact, this is horizontal legislation, so it affects all products with a digital component, not just factory automation, but that laptop over there, if you have a digital watch, if you have a baby monitor, all of these are within the scope of the Cyber Resilience Act. And there are specific responsibilities for manufacturers, for importers, and for distributors. So we all really have responsibility when this enters into force. Now, to look at specifically what it's about, on the 12th of March this year, I think it was approved by the European Parliament, and it now needs to be adopted by the Council. So if we think of when it will enter into force, the idea is around the time of the EU election. So maybe June, July, it will enter into force. That means we will all, that fall within the scope of this regulation, we will all have a 36-month transition period, meaning from the time that the law is ratified, we have 36 months to get to the point where we can comply. But there is also a 21-month, so it's a shorter period, where we need to comply with reporting requirements. So there are different requirements for the Cyber Resilience Act. The shorter one is reporting. Reporting is very important in cyber legislation. So it's not just for the Cyber Resilience Act, it is also for NIS2. So let's look at a few aspects of the Cyber Resilience Act. The goal is to create a coherent cybersecurity framework. Again, this coherence is horizontal. When we talk about factory automation, it's some industries, but there are many, many others that are also covered underneath this. As part of a product that you will place on the market within the European Union, that now needs to include a cyber risk assessment. Also, when you look at your laptop, when you look at devices, we have a CE mark that's part of the product. That CE mark will indicate a declaration of conformity. And lastly, so I'm just highlighting some aspects of the Cyber Resilience Act. Lastly, manufacturers must have a coordinated vulnerability disclosure policy. It's all about reporting. It's all about informing everyone. And this is also part of the Cyber Resilience Act. Just quickly looking at Mitsubishi Electric's involvement. We've been actively involved in the Cyber Resilience Act. We've provided feedback to the European Union, and our feedback is actually available for download from the European Union website. So that's the Cyber Resilience Act. Then briefly, let's move to NIS2. So NIS2 is around organizations providing essential services. Now, we would think critical infrastructure, but NIS2 is actually more than just critical infrastructure. It involves, normally in the scope of this legislation, organizations with employees sizes of more than 250. So these are relatively large organizations, but there are very specific criteria for who would fit within this legislation, who would be within the scope of this legislation. let's look at when. NIS2 actually entered into force January of last year already, and there's a transition period until October of this year. The final jurisdiction for this legislation is with each European Union country. But the European Union itself wants to set let's say, a minimum baseline that everyone needs to adhere to. So we said NIS was the first one in 2016. NIS2 is already ratified, but it's a wider scope of sectors. We talked about critical infrastructure before, but this now also includes waste management. It includes pharmaceutical. It includes food and beverage, social media platforms, cloud service providers, postal and courier services. So this would not normally be within critical infrastructure. Well, I wouldn't have thought so, but that's why the terminology is now organizations providing essential services. And to summarize NIS2, it's a very big document. I invite you to go and read it. But to summarize, there is management responsibility and liability for including a cyber risk management program within the organization. I've written down Article 77. So if I may, I just want to read it. So Article 77 states that responsibility for ensuring the security of network and information system lies to a great extent with essential and important entities. A culture of risk management involving risk assessments and the implementation of cybersecurity risk management measures appropriate to the risks faced should be promoted and developed. All about managing risk. This is what most of the cybersecurity legislation, not just in the European Union, but around the globe, are trying to address. And maybe lastly, just to mention on this too, there is also specific reporting obligations. We talked about Cyber Resilience Act. There are reporting obligations. The same thing here, incident reports, vulnerability reports are required for NIS2 as well.
And I think that what you just said about, mitigating risks, I think that's one of the reasons why the NIS scope is being expanded, because I have a feeling that we are more and more dependent on all of the services that are around us. I mean,
exactly.
You can't live without water in your house for more than like one day, I guess. And the same goes for like many different services that we are receiving. And like in the current geopolitical landscape, especially in Europe, I think that the risks are only growing, right? So
That's right.
Being able to mitigate them is a very important point and aspect of designing everything. And I think, again, we will talk about it soon, but you mentioned reporting couple of times. And what was surprising to me is that reporting comes first. Before you act on some threats or you try to make your systems more secure, it's much more important to do the reporting first. And could you tell us why is that?
Yes, I can. Maybe just to mention, you said we can't do without water, and I agree. So water is a critical component. But if you ask my kids, they will say they can't do without social media platforms. That's also within essential services.
It's like water to them. Huh?
Exactly. So it's quite interesting. In fact, turning off the water won't be recognized as quickly as turning off the Wi-Fi. But that's for another discussion. So maybe we will now talk about reporting. And part of reporting is around the world, organizations have product security and incident response teams. So they look for vulnerabilities, they look for incidents, they try to be on the forefront, they try to inform their customers and their users and the government as well. Now, the most widely accepted reporting framework is the CVE program. Now that stands for Common Vulnerabilities and Exposures, and it was established in 1999 already. It is recommended by governments around the world. Very well-known organizations have partnered with the CVE program. So it's a very mature program. And when you look at a vulnerability report, so an organization releases a report that says, we have a product and there's a specific vulnerability. The CVE program has a recommended approach. So firstly, it's got a unique number. Unique across the globe. If you search for that number, you'll find exactly that vulnerability. It also has a year, so you can, the date associated, you can as an organization, understand when it was released, when this vulnerability have actually been reported. When you look at the descriptions, there's normally a short description, mitigations, patches, if there are patches, an advisory. So everything is contained within this report. Maybe to mention quickly, there's not always a fix immediately available, and that's okay. When you report a vulnerability, you normally report mitigations at least, workarounds. And when we talk about defense in depth later, we'll notice that it's completely within the scope to have some mitigations and workarounds initially. The patch can come later. We are reporting early. So anyway, when we look at the CV report, we said it's got all of this information, and it also has a CVSS score. We're using all these big names and acronyms, but CVSS is Common Vulnerability Scoring System. So it's not a big deal, and it is a number between 0 and 10. So when you look at a vulnerability report, you get this number between 0 and 10. 10 is the most severe, and 0 is of no impact. And so it makes it easy for an organization to look at this vulnerability report, very quickly look at the number, and for example, they may have a policy that says, if the number is higher than 9, we need to implement the suggestions, the advisory, as soon as possible. If it's, let's say, between 6 and 8, we can do it within the next maintenance period. So it's a very quick way of assessing the severity of the vulnerability. So that's the report. We talked about the unique number for this report. These numbers are assigned by CVE numbering authorities. They have the right and the ability to assign these numbers for various vulnerabilities within their organization or within their partners' organizations. So these authorities join forces with the CVE program. Mitsubishi Electric is a CNA, a CVE numbering authority. And this CVE process is integral to the product security and incident response team process within Mitsubishi Electric. There's a team at head office, and there's a team at every factory, and they work together with security organizations around the world. They make sure that when a vulnerability is mentioned, how do we go about addressing it and reporting on it. Lastly, the CVE program is widely accepted by legislation, also NIS2 and the Cyber Resilience Act.
Mm-hmm. But just to maybe simplify this a little bit, because obviously it's the whole process which was designed, having, security in mind and, well-being of people and companies. But generally speaking, the point is that it's not only about, reporting that something happened, but also like giving you indication whether this was severe or not.
Yes.
And also usually a good company that has some, vulnerability in their product, they will be trying to give you some hints how to overcome the problem for the time being before the error is solved, right? So that's why reporting comes first when it comes to cyber topics, right? Okay, so let's say that we have discovered, and let's say that organizations know now where to look for the information and how to understand the reporting from, like, for example, manufacturers, vendors, and so on. But then what? So how would you actually implement cybersecurity system to protect your company, your water treatment facility, or whatever it is, how you can actually comply with the Cyber Resilience Act and so on?
I think this is the big question. We know legislation is either already in force or it's coming very soon. And the big question is how? How do I approach this? We have a saying, how do you eat an elephant? One bite at a time. And this also applies here, where we can really look at standards. And I'm going to mention a specific standard, but standards and legislation go hand in hand. Standards are often used to underpin the technical requirements of the legislation. So when you get legislation, with the legislation, there is a list of standards that's provided either as an addendum, an appendix, or directly in the legislation. These standards that are listed are called harmonized standards. And when an organization looks at legislation and they want to comply, and they implement within their organization a harmonized standard, they are set to achieve a presumption of conformity, meaning before an audit takes place, before someone comes to have a look, have you implemented NIS2 requirements? they can already presume they comply, they conform, because they've taken a harmonized standard and they've implemented it within their organization. So when we look at OT, operational technology, factory automation, IEC 62443 is an example of a harmonized standard. And actually, it's not just one standard, it's a group of standards. And this specifically focuses, we call it IACS, Industrial Automation and Control Systems. So industrial automation, operational technology. And I mentioned it's quite a few publications. So there are 4 levels of IEC 62443. At the top, you get general, then you get policies and procedures, then you get system, and then you get component. So you can see we focus on the organization first, and we slowly move directly down into the component. And IEC 62443 provides a standard at each of these levels for us to know what's required. What does the standard say? For example, let's look at numbering. You get IE 62443-2-1. So it says it's at the policies and procedures layer, and 1 means it's the first publication. And this one is establishing a cybersecurity program for automation, for factory automation. We're not talking IT, talking OT. So specifically for factory automation. When you move 1 level lower, at the 3 level, there is, for example, a risk assessment for system design. There are specific security levels for the system. And lastly, at the bottom, so now -4, you get IEC 62443-4-1. And this is the secure development life cycle for the component, so it applies to manufacturers. And to note here, Mitsubishi Electric is IEC 62443-4-1 certified. So during the manufacturing process, during every step of the way, design, manufacturing, testing, all of these steps require and include a cybersecurity aspect. So when it exits the factory, it's cyber safe by design.
But what you just said, so I think there is a common misconception that just simply having the products that are, certified, this makes the factory certified. I mean, at least protected. But that's completely not the case, because the product certification is actually the last in the order, right?
Exactly. That's right. So 4-1 is the last one. We're focusing on component. We should go and look a little bit higher. 2-1 is where an organization can start. This is a good guidance for organizations that want to comply with NIST 2, for example. Have a look at 2-1. It specifically focuses on what they call asset owners. These are organizations providing essential services. How do you establish a cybersecurity program for automation? Again, we're focusing on automation. There is another standard, ISO 27001, which applies to the organization from an information security management perspective, IT. Here we are talking OT. And, we can also help organizations in understanding what aspect of 62443 they can apply to achieve this presumption of conformity.
Okay, let's focus on the cybersecurity for factory automation systems. And as we just established, having certified products is not even the beginning, it's actually the last step in the whole process. Right. So maybe let's talk about practical implementation and what kind of practical steps you can take to actually protect yourself from cyber threats.
Maybe I should start by saying many of those that are joining us today, they're already far ahead in their journey towards compliance, towards a cyber-safe environment. So I may repeat things that they already know, but I think we can start with 2-1 as well. And maybe just before we start with 2-1, there is no such thing as perfect cybersecurity, as a completely cyber-safe environment. We need to find the balance between risk versus cost versus complexity. I always say, with increased security comes increased inconvenience and often reduced performance. So, it's our task to find the right balance. But let's quickly look at 2-1. Start with a risk assessment, all about risk. Decide how you will address this risk. Do you mitigate the risk? Do you outsource the risk? Do you eliminate the risk? And then the third step is continuous monitoring and improving. So, of course, this is very high level, and there are very concrete steps, such as establishing a business continuity program. incident reporting, what to do in the event of an incident. In fact, assume an incident will happen for your organization. How will you go about addressing that? Staff awareness training, physical access control. All of these are also provided as part of 2-1. But I think you asked some concrete actions,
Yes.
some steps. And here, let's discuss defense in depth. So defense in depth is not specific to Mitsubishi Electric. It is a very common concept. And we are saying one component or one action within the organization cannot achieve perfect security. We need to apply cybersecurity at various layers within the organization. We want to harden our organization and our system, our OT system. We want to improve our cybersecurity posture. This is all done through a defense in-depth mechanism. For Mitsubishi Electric, we focus on 4 of those layers: human, physical, network, and component. So at each of these, we can do some things that will help us harden our system and improve our cybersecurity posture. If I can use a few examples, at the human layer, we need to create a automation security policy, cybersecurity policy for the organization. We need to clearly define roles and responsibilities, chain of command. What should I do and who should I report to if something happens, if it happens now? If we look at physical, first start with a structured physical access environment, physical access control. That's the first step.
Actually getting the access to the component itself.
Exactly. Mm-hmm. If you have physical access, it doesn't help we look at network controls and we look at component because there's physical access. So physical access first. Prevent unauthorized access to network equipment, to Wi-Fi access points, to cabling, to operator terminals. How do we prevent physical access? And then maybe another step, don't allow the connectivity of personal devices, of any device that shouldn't be on the network or within that physical environment. Mm-hmm. So these are physical. Let's look at network. Start by creating secure zones and conduits. Zones and conduits are really a concept in IEC 62443. We start with a network diagram. We look at the system and we say, which parts are very sensitive? How do we control these parts, the sensitive parts with many layers? So we start with zones and conduits. We create network segmentation through firewalls, through VLANs, maybe a DMZ or a DMZ, demilitarized zone, for applications requiring fine-grained control. We control internet access. What component is allowed to connect where? Very controlled. And we make use of encrypted communication wherever possible. So these are just some examples. Again, this is not an exhaustive list, and I'm sure those joining us today have a much wider list. And you know, it's cybersecurity is a team effort. We are here to help each other. That's why I like the reporting side of cybersecurity. We also, as a country, as a union, and you know, in general, are there to help each other to create the cyber safe society. But I digress. So let's just come back to the component. So we talked about the network. Let's look at the component. Some examples. Ensure encrypted storage. So when you save something, is it encrypted? Make sure that communication from verified sources only is allowed. Here we can take some guidance from OPC UA. OPC UA is a inherently cyber safe communication protocol. And for example, we can create pre-established trust. So we know these components are trusted because they make use of digital certificates and therefore they are allowed on the network, for example. Sorry, go ahead.
But the picture that is appearing, at least to me, is that, well, first of all, there is no finite amount of things that you could do
Absolutely.
to protect yourself. And that's why I think this topic is perceived as very complex.
Yes.
Because all that you described might be too much for some factories and not enough for some others,
That's right?
So I think that that's why what makes it very complex. But I think that the second message from this explanation is that you need a holistic approach. So it's not enough to focus on the network or on the device. You need to look at all of the places at the same time and create a system that doesn't neglect some of those spheres,
Exactly,
right?
exactly. I think, you know, just coming back to device, one of the aspects when we focus on device security is product disposal. So this component is no longer used. We also need to ensure proper product disposal from a cybersecurity aspect consideration. So let's say this laptop, for example, we need to make sure that all sensitive information is removed before we send it to recycling, for example. So, and like you said, there are so many aspects. There's sometimes, where do I start? Start somewhere, at least. Start at the top layer. This is what IEC 62443 says. Start at the organization. Cybersecurity is a team effort. So start at the top. We are going to create awareness. Once we have created awareness, physical is more important than the other two. Mm-hmm. And then we move down. So I would say start at the organization.
Mm-hmm. Okay. All of that makes sense to me, but I am still, let's say, interested in one particular area.
Yeah.
So we discussed that there are specific strategies for the factory automation or the operational layer in general. And of course, the whole IT industry has a lot of different approaches to this as well. I think it's equally or even more important in IT. But with the smart factories and all the concepts related to making factories smarter, there is another trend that we maybe briefly discussed, but maybe we can go into details, which is IT-OT convergence.
Yes.
So because the technologies that we are using in OT are getting smarter, there is this situation where IT and OT are coming close together. The boundaries are not so sharp anymore. And clearly, this affects also the cybersecurity approach.
Right.
So could you give us some hints about how to handle that?
Yes, I think that's a very important topic. And this OT-IT convergence are increasing. When we talk about IT, we talk about enterprise resource planning systems, ERP systems, business systems, relational databases. All of these now need to be connected in some way with OT systems, whether that is MES systems, manufacturing execution, SCADA systems, whether it's directly to the controller or to the robot, for example. We see this convergence accelerating. And both IT and OT are working towards the same goal: risk mitigation, threat prevention, reducing cost, reducing complexity. So we are working towards the same goal. But the IT priorities sometimes don't fit the OT world. And sometimes IT policies are being forced on the OT environment. And this creates not only a convergence, but sometimes I'd like to call it, well, don't like to call it, but that's what it is OT-IT collisions. Mm-hmm. So we sit around the same table, and all of a sudden IT want to force their policies, and OT is sitting back. IT has a lot of experience on cybersecurity, and we can learn from them. But at the OT side, we need to say, let's find a balance in the middle. And from this point to the IT side, we use ISO 27001, and there are some general concepts, but from the system and lower, we follow OT policies, IEC 62443. And this creates a harmonious environment, because when you open your laptop, for example, and you switch it on and you need to start this podcast, and someone needs to do an update right now, that can happen, and you didn't plan it, all of a sudden, you're sitting waiting for the update to finish. And in the IT world, maybe this is not life-threatening, mm-hmm. but in the OT world, safety is a priority. So let's talk about priorities. OT, let's talk about IT. IT, it's privacy, and security. OT, it is safety and resilience. We want to keep production up and running. Because of these priorities, we need to find that middle ground. Where do we work together? And this is at the system level. And this is where IEC 62443 helps us. So when we sit around a table with IT, we bring everything on the table. OT talks IEC 62443, and this is how we join forces with IT. I've written a few do's and don'ts. I'm not sure if we have time. I can read a few. Otherwise, we can always list it on
maybe the main later. Ones, yes.
Okay.
So the main do's and don'ts related to, let's say, avoiding collisions between those worlds.
Okay, yeah, that's a good point. So I've written down, don't apply all IT security policies for all components. For example, anti-malware on an embedded component often reduces performance. It doesn't really make sense. and do evaluate the system as a whole. So apply IT policies and continuous updates at the system level. Be selective at an OT level. Don't apply irregular updates. I know this sounds like common sense, and I apologize if I'm saying things that are very common sense. I just find that the problem with common sense, it's not always that common.
I don't think this is common sense, because often talking to manufacturers, like for example, people who are responsible for industrial networking, so the networks, the field networks, right?
Yes.
So they're connecting different production lines and so on. And they often complain that it is very difficult to find a common ground with the IT.
Yes.
Yeah. So
Yes.
the IT wants to protect the network as it was LAN, which is clearly not the case, right?
Exactly.
So this is not a common sense, but of course we cannot blame IT. I mean, they have their priorities.
That's
they
right.
have to,
That's right.
fight for it, right? So
Our goal, we can also educate IT. IT can educate us. They've been around in the cybersecurity world maybe for longer, a lot longer than OT. But together we can help each other. I'll list one more. And this is, don't have the IT network and the OT network on the same cabling. So don't have them on the same network device in the same subnet, for example. Separate OT and IT. And maybe one last one. It is very easy if there are unsecure USB ports. With increased inconvenience, increased security, but the same goes for decreased security is convenience. So there's an operating system which I won't mention, but if you plug a USB in or you insert a DVD, it will automatically run that. This is an invitation for hackers. Just plug something in and it will automatically run it. So disable any unused USB ports and make sure that those kind of conveniences are switched off. There are a few others, but we can list them later in the podcast.
the one that comes to my mind, though, is that a lot of companies are nowadays thinking about using data analytics on the edge. So analyzing the data, understanding what can happen, like how we can modify the process, and then implementing the decisions directly on the factory floor.
Yes.
So the data that never leaves
exits the premise.
Yeah.
Absolutely.
So would you say that would be one approach?
I think that's a
mitigate the
very
risk?
good idea. In fact, maintain on-premise as far as possible when it comes to security. However, there are certain computing environments, for example, AI initiatives, that are just far better on the cloud. So we're saying, how do you actually connect the two to each other, and how do you have the edge communicate only what's needed? But for edge computing, do the calculations as far as possible, as close to the data as possible. So
Yeah.
I agree.
Yeah, and that's why I think that more and more often we have this kind of conversations. Okay, so we are almost done, and we will move to Q&A shortly. But you mentioned all of those, let's say, technological aspects, but maybe we can list some specific technologies that you are working with. So could you share,
Yes.
very briefly, but could you share like what kind of technologies you are working with these days?
I think let's start by talking about OT cybersecurity partnerships within Mitsubishi Electric. There is a partnership with Dispel for zero trust access to ensure reliability, uptime, and crew safety. So this is Dispel. There's a partnership with TX1, which is a very well-known OT cybersecurity company for OT native network segmentation and other cybersecurity technologies. And then there's a partnership with Nozomi Networks for network visibility and intrusion detection services. So we are trying to create this complete cybersecurity ecosystem, and a part of that ecosystem is partnerships. When we look at Mitsubishi Electric specifically, I'll quickly mention just two technologies. One is OPC UA, which we have briefly mentioned before. OPC UA has cybersecurity inherent in the protocol, and Mitsubishi Electric has hardware modules for OPC UA, software modules. So OPC UA is very well integrated within Mitsubishi Electric. And the second one, the upcoming MX controller. So the controller line, it satisfies IEC 62443-4-2 requirements. It has technologies for confidentiality, for authentication, for integrity, transport layer security. This is all inherent within the controller. Maybe those are the two that I want to mention.
Sure. And yeah, I mean, we could spend a little bit more time on OPC UA because it is a very important development when it comes to protecting the communication internally in the factories. But okay, not today because we don't have enough time. However, we can consider a small conversation about it in future. Okay, so we are almost done, and I just was thinking about how to summarize this podcast, but maybe I can ask you to do that. So, how the whole conversations we spent 40 minutes talking about cybersecurity, and clearly it's complex. I mean, I could understand quite a lot, but I can see that this can be difficult for many manufacturers. Is there a way to summarize this?
This is a very difficult question, how to summarize. And I would say, please re-watch the podcast to summarize for yourself. So have a watch afterwards, and then you can find the summary.
Yeah, I think this podcast, which will be published on YouTube, hopefully this week still, I think it will be a nice source of information, and rewatching it and maybe, referring to some of the documents that you mentioned. I think that's a good place to start with cybersecurity. All right, so maybe we can answer a couple of questions and then we will wrap it up. So let's see what kind of questions do we have already. There is a question about defense in depth concept.
Yeah.
So can we do the defense in depth based only on network and devices? So taking part of the concept and focusing on those network and device, areas.
I think a network and device are easy to implement in a remote environment. So can you only do it on network and devices? Yes, you can. Would it be blocking all the cyber attack holes, let's say? If you don't have a structured physical access environment, then I would say it doesn't really help if you only apply it at those two levels. Of course, it's much better than nothing. So can you? Yes. Do I recommend it? If you want to start like that, sometimes those two, network and component, are the easiest access points, even easier than physical access control. So yes, you can definitely start there. Find network visibility. Sometimes we don't know what's happening on the network. So it's a good start, network visibility. What's actually going on? How do we trace this? When we look at bad actors on the network, when we look at attackers, they often won't let you know that they're on the network. Surveillance happens for at least 6 months. In fact, research have shown that they are on your network for between 6 and 8 months before anything happens. So find network visibility. The question is around network and component. Yes, and I would recommend as part of network, have something that shows you network visibility. So then you can trace little things that are out of place that won't maybe be visible because of all the noise that's happening in the meantime. So I know it's a long answer. Cybersecurity almost always have long answers, unless the answer is turning off the electricity. Because then there's perfect cybersecurity. But you can start there.
Yeah. However, I think that to make the full potential of the concept, I think that at least you should be trying to cover all areas.
Yeah, I agree.
Okay. The next question is about the reporting, and it's an interesting question. So, what is the difference?
As in difficult?
I don't know. Maybe no. What is the difference between incident and vulnerability reporting?
Okay, very good question. When you look at incident reporting, this normally applies to the actual manufacturer, the essential service provider. Something has happened, a breach, a data breach, for example, a hack attempt or a successful attempt. Maybe you're an energy, you're a power provider, and a hack attempt happened. You need to disclose this. There was an incident, I'm disclosing it. Normally, I have to disclose it to a regulatory body. I need to tell them, we've had an incident, this is how we've addressed it, and they can decide how to proceed. So an incident applies to the organization. Vulnerabilities applies to the manufacturer, normally. So I'm placing a product on the market. You've bought the laptop. There's an operating system on the laptop. We've, as the manufacturer, have noticed a vulnerability. So now we inform all our customers. We also inform a regulatory body. This is where the CVE program comes in. We inform them that the vulnerability has been found and what do we advise? How do you work around it? Incident applies to organization, vulnerability applies to the product or the component or the service.
Okay. Both important though. The next question is, where can I read the regulatory references on our products? So I assume our products means Mitsubishi Electric products.
Yes.
And I would
That's a good question.
say the website would be my first guess.
But maybe, so regulatory references. This is a good question. Where do I start? So Mitsubishi Electric has a information security management document, a very large document that describes how cybersecurity is implemented within the organization. We're not looking at products yet. We're just looking at information system management. Just search for ISMS Mitsubishi Electric. You will notice that there's a very nice document outlining the basic approach to cybersecurity management. The second step is, yes, the website is a good answer, but if you want to search, or just go to Mitsubishi Electric website and go to the PSIRT section, Product Security and Incident Response Team section. And there you'll find a lot of information. And lastly, of course, we've published a white paper, and this is available for download. So the white paper would be a good starting point. And it's not really in so much technical terms. So the white paper will also guide you in what's implemented in Mitsubishi Electric from cybersecurity.
I think so. So the white paper is a lengthy document, but it gives you quite a lot of insights, I think. Yeah. So maybe we can also publish some links later to the chat. Okay, just quickly checking whether there are any other questions. It seems we cover, because there are 2 tabs, but I think we cover all of them.
Maybe we can talk a little bit about AI.
Sure.
Just quickly, because AI is a hot topic, and it is, cybersecurity is also an aspect of AI. And, I've mentioned AI is quite useful on the cloud, sometimes far better on the cloud. However, and when I talk about AI on the cloud, I talk about managing petabytes of data. So this is for organizations that already have AI on premise. Then you move it to the cloud. So AI on the cloud is almost the second step, in my opinion. Why I'm saying this is there's a cybersecurity requirement when you send it to the cloud, but the first step should be AI within the organization. So doing the AI within your factory, doing the calculations already there, and then the calculations that can't happen there, you can decide, is it safe? How do I not leak any sensitive information when I move that to the cloud? So maybe, at some point in the future, we can also have a discussion about where's the overlap between AI and cybersecurity. But what I wanted to say is cloud is important, AI, because you have a lot of computing power. But before you even consider the cloud, my recommendation is see how you can implement AI within the organization first, as close to the data as possible. It's also more cyber secure that way.
Yeah, and actually, that would be the whole topic itself. I mean, AI is getting quite a lot of attention, and it's not surprising. Also in manufacturing industries, because it actually helps you to increase the productivity without really speeding up anything anymore. I mean, maybe what AI can speed up is decision making about the component and the quality parameters and so on. So clearly, sooner or later, AI influence on cybersecurity will be a huge topic.
Correct.
So we can discuss this at some point in time.
Yeah.
And it seems we will never run out of topics to discuss, because we have another recommendation to have a future talk about OPC UA.
Okay.
As I thought we will.
Yes. Can I mention something about
please.
OPC UA? So OPC UA is a specification where normally competitive organizations work together to create a specification which all can use interchangeably. And Mitsubishi Electric is part of this working groups. In fact, we are very integral part of the OPC UA process, along with many other large manufacturers. So we are directly defining the specification. And one of the working groups in the OPC UA Foundation is the Cybersecurity Working Group. And it's their responsibility to ensure that any requirement, whether it's for communication, whether it's for authorization and authentication, all of these are considered through the glasses of cybersecurity as well. So just to mention, we can definitely talk a lot more about OPC UA, but we as Mitsubishi Electric are on all the working groups that define the specification as well.
Mm-hmm. Yeah, and would you say that you see a future where all the important systems in factories are communicating through OPC UA?
I see it as a definite possibility, and I would recommend it in a large way. There are certain things that require very specific protocol, but if you want to consider a cyber-secure protocol, you are designing a new section, you want to perform maintenance on another section, OPC UA provides interconnectivity between different components from different suppliers and also between organizations in a cyber-secure way. So definitely I do see that.
Mm-hmm. Okay. Last question related to components that are already certified with 62443-4. Could you give us outline which kind of product ranges are compatible?
Okay. So when we say 62443-4, there are actually two standards, -4-1 and -4-2. 4-1 is around secure development life cycle. And this, Mitsubishi Electric is certified for all products. Mm-hmm. So every product exiting the factory, controllers, GOT terminals, inverters, name it, it is part of the process. So for all of that, we are certified. The second one is 4-2, and this is at the controller itself. There are specific security levels that you need to adhere to, some requirements. There's a huge list of requirements for each individual component. And there, specifically, when we look at 4-2, the new MX controller from Mitsubishi Electric is 4-2 compliant. Mm. And there are many inherent cybersecurity technologies. That doesn't mean that those technologies are not on some of the other ranges as well. There are many, IP protection, IP filter protection, but there's a focus with the new MX controller to get certified on 4-2, at least as a first focus.
But as long as the manufacturing process is concerned, it's for all products. Yeah?
Correct,
So, yeah.
correct.
Okay. We spoke about AI just a little, but there is a question. What do we think about the recent EU AI Act and other future AI regulations?
Yeah.
How they affect the cybersecurity?
That's a very good question. And cybersecurity is actually part of that legislation as well. I think, in a way, when it comes to legislation, the European Union often leads the process for legislation around the world. And this is also the case with the AI Act. It's a way to protect, again, we focus on sustainable societies. Mm-hmm. It's a way to protect societies. AI, in my opinion, in and of itself, is a very positive development. It's the same with the internet, very, very positive. But it can also be used for harm. It's neutral in itself, but the AI Act is helping to safeguard us, to provide some limits, some borders around what is allowed with AI and how it should be managed. And again, so what do I think? I think it's a very positive development, and there are also cybersecurity requirements listed within the AI Act. There, I think the European Union is actually leading the way for globally for all other regions as well.
Yeah, it's happened already a couple of times. Some say that it slows down the innovation, but then again, if we are talking, as you said, the sustainable society is also cyber-secure society. Yeah. And I think this is a very important thought because, especially today, one way of destabilizing our countries in Europe is through cyber threats. So
correct.
I think that you are completely correct about sustainable society and the importance of cybersecurity in it. Yeah. So.
Yeah, you're right.
Okay, that was very cool conversation. I think, especially I think because the topic was so heavy, but you made it really easy to understand. So I'm glad you were here. Thank you, Fritz. And
thank you for having me.
hopefully we will talk again here.
I appreciate it.
Thank
Thank
you.
you.
Bye-bye.
Bye-bye.